yeah, just on my computer's good. Right there. Perfect. Thank you. All right, good morning. This is section 3.5, completing the square. All right, we are studying quadratic functions, and quadratic functions are parabolas. And we are learning all the different ways to solve quadratics. And when we solve, we are finding the x-intercepts. That's the nuts and bolts of solving equations, of solving any equation, really. We're finding the x-intercepts when we're solving for x. Now, our problem exists in that here we have two real solutions, but more often than not, we have a parabola that's floating in outer space. What about this parabola? How many solutions does this parabola have? This one has two real solutions. But what about this one? No real solutions. It doesn't have any real solutions. No real solutions. And by real, I mean actual solutions in the real world. Instead, it has two imaginary solutions. Yes. Two imaginary solutions, and we talked about imaginary solutions before. What letter do imaginary solutions get? I for imaginary solutions, and they always come in pairs. There's always a plus or minus. We're going to be revisiting that today, and we are going to learn a new technique for solving. We've been factoring and solving. We've been double bubbling and solving. That's what our goal was this previous few days. And today we're going to learn a new technique called completing the square, which I love. I think it's great. It works really well. And to get us going here, I have what are called algebra tiles. How many of you have seen algebra tiles before? 5 or 6. Okay. I love algebra tiles, and I wish that we had, more time where we could play around with them a little more, but they're really great. This tile represents x squared. It's x being squared. You'll notice the shape of it. It's a square, right? It's pretty amazing that that's x squared. It's literally a square. This is 1x, and this is a unit cube, just a single unit, okay, 1, all right? And you'll notice that the x times an x times x gives us x square. X as a square. That's what it gives us when we multiply x's together. It gets us a square. So when we're completing the square, that's exactly what we're doing. So you don't have to write this down. I just want you to watch right now. Why is it called complete the square? So the first thing we're going to do is we're going to represent this little polynomial here. X squared plus 6x plus question mark. We want to figure out what is needed to complete a square. So I have 1 x squared, and I need 6 x's. So there's 1x, 2x, 3x, 4 x's, and 5 and 6 x's. So this is this expression in algebra tile language. Okay? Kind of interesting, right? So when we're completing the square, our job is to create a square. So I need to rearrange these pieces. I'm going to take these 6 x's and sort of play around with them so that I get a nice little square with no gaps or holes. And so you'll notice here I'm going to take 3 of those x's, and then I'm going to take the other 3 x's. I still have 6 x's. I've just rearranged them. And then you'll notice I almost have a square, and this is the part that's missing. And this is our job today, is to figure out what goes in there. Well, what goes in there? 9. There's 1. I'm not going to fill it in all the way, but just to give you the idea. 2. How many of these little yellow things are going to fit? 9 little yellow units. All right? 9 would, in fact, complete this square and fill it in so that there's no gaps or holes or anything. 9 of them. That's fantastic. Okay, so let's try one more time here. I have, again, over here, I have an x being squared, so there's one of those. And I need 10 x's, so I have 6, 7, oh, this is 8, 9, and 10. There's my 10 x's. Check.
So we're just like making a square and you just fill it in?
Pretty much.
Just count the yellow thing?
Yeah, that's it. Although you're not going to do it with algebra tiles.
Is there just a formula?
There is. Yeah. What is it? What do we have to do with the 10 x's here? All right, there's I got 10 x's. I got it in a nice square shape. So this is the question mark. What goes in here? What? 25, yeah? All right, we got 1, 2, 3, 4. I'm not going to do 25, right? But this is just 5 times 5, right? So 25. So what do we have to do, Calvin? Half.
Half of the number is squared.
Half of the 10x, half of the 10, that's 5. And then we just create a square out of it. So you square. That's exactly right. Ladies and gentlemen, that's the formula. Take those x's and split them into 2 groups, and then complete the square. That's just take that number and square it, okay? Very cool. And I love how that works. So let's give it a go. So now, example 1. Here is your work. And this is not all we're doing. This is the first step in the process. But I love the first step because it is so easy to see when you play around with it for half a second. Example 1, what value would complete the square? What value would complete the square? So we want to know what goes in this little blank space here. Well, what would we have to do with these 14 x's? Just 14 of them? What do we have to do? Divide by 2. 14 divided by 2 is 7. And then we have to do what? Square it, which would be 49. That's what goes in that blank little space. That completes the square. If you're thinking about standard form, ax squared plus bx plus c, okay, what would be a formula to figure this out? Instead of using numbers, what if we just represented things with letters? What do you think that formula would be?
B divided by 2.
B divided by 2 squared. That's the formula. That the c value is b divided by 2 and squared. But what I love is, did you need a formula or did you know what to do? You just knew what to do, right? Once you see it, it makes so much sense. Let's look at this one. Again, if we want to figure out what completes the square here, what do we need to do? Negative 10 divided by 2 and square it. Negative 10 divided by 2 is negative 5. And when we square, what do we get? Positive 25. Remember, this is negative 5 times negative 5. We should always, always, always get a positive number. Really important. Okay? Keep that in mind. That's pretty easy to do, right? Not hard at all. All right, let's see what we do with it. Okay. Solve for the roots in simplest form by completing the square. This is the goal for today. Solve by completing the square. And this involves a lot of things that we've been doing. We learned about i's, so we're going to be using i's on occasion here when it's necessary. We have to be able to simplify radicals. And we are solving using the square root method and completing the square. It's a whole bunch of things combined. All right, we have x squared minus 4x minus 32 equals 0. Ladies and gentlemen, please take super good notes because this is a long process, okay? Write everything down. The first thing we want to do is isolate the x squared and x term. That is the first thing we want to do. Isolate the x squared and x term. Okay. In order to do that, I'm going to add this 32 to the other side. So I'm going to add 32 so it's away. So I have x squared plus 4x equals 32. You notice I left some space here. Oh, thank you. Thank you, thank you. I was reading on my Facebook reel that someone has a mistake counter on the board, and I should totally make that too. Okay. All right, so you'll notice I left some blank space here because we need to complete the square. Now, what we're going to do for this second step is complete the square. Complete the square, but you'll notice if I add something on the left side of an equation, what must I do? Add it on the right side. I got to keep it balanced. So I have to complete the square. I have to add the same number to both sides in order to keep our equation balanced. Okay? What goes in this blank space? 4. How did you get 4?
4 divided by 2 squared.
Yeah. Negative 4 divided by 2 squared. Negative 4 divided by 2 is negative 2. When you square that, negative 2 times negative 2 gives me positive 4. So we're going to add 4 to both sides. Well, that was easy. Why do we do that? On this left-hand side now, we have a trinomial. Third step. What do you suppose we can do with a trinomial? Factor it. Double bubble. Double bubble. This is why we had to learn how to double bubble. This factors. Ladies and gentlemen, what times what is x squared? X times x. And then what times what is positive 4? 2 times 2 or? Negative 2 times negative 2. And that's what we want. We have 2 times 2 or negative 2 times negative 2. And I need the negatives to get a negative middle term here. Negative 2 times negative 2. How do you know if you did it right? Check the rainbow. If I check the rainbow here, x times negative 2 is negative 2. Negative 2 times x is another negative 2x. Negative 2x and negative 2x gives me that negative 4x middle term. Okay? That's fantastic. Can I clean up this right-hand side? What's 32 plus 4? 36. Okay. You'll notice this is kind of an interesting thing here. It's a repeated factor. I'm going to clean it up. I'm going to consolidate it. I'm just going to say x minus 2 quantity squared equals 36. Isn't that nice and neat? It's really tight, isn't it? In this form, now we can square root. We're going to double bubble and write it as quantity squared. We're going to use the square root method to solve for x. Now that we've got it written as something being squared, I can use the square root method. How do I get rid of this power of 2? Square root. We can take a square root of both sides. What do you have to remember when you take a square root? Don't forget the plus or minus. Don't forget the plus or minus. Don't forget that plus or minus. What happens when we take a square root of something squared? Can cancel out. They undo one another. They cancel each other out. What are we left with?
Plus or minus x minus 2 equals plus or minus 6.
X minus 2, and we only need one set of those plus or minuses. X minus 2 equals plus or minus. Ladies and gentlemen, what's the square root of 36? 6. Very good. And now, can we get x by itself? Which, add 2. We're going to add 2. I'm going to insert that 2 right in front. We get 2 plus or minus 6. Do you think this is a good answer? We're not quite done. We have one more step. These are both regular numbers. I can evaluate it. This would be 2 plus 6 or 2 minus 6. What is 2 plus 6? 8. What's 2 minus 6? Negative 4. These are our two solutions for x. You will almost never get one of these from me because you'll notice these numbers are pretty nice, aren't they? Well, when in doubt, graph it out, right? X squared minus 4x minus 32. Let's take a look. Where did this parabola cross the axis? 1, 2, 3, negative 4. 1, 2, 3, 4, 5, 6, 7, 8. Positive 8. Could you have taken a shortcut? Sure. All right. This was just for learning the process. I won't test you on that because you could use your calculator, huh? So you got to learn the process so that we can find things that are imaginary, and that's our goal. So we will get there soon. What's different about letter B here?
There's a coefficient on the x squared.
There's a coefficient on the x squared. There is a number in front of x squared. We do not complete the square when there's a number in front of the x squared. But you'll notice all of these numbers are divisible by 5. Ladies, let us go ahead and get rid of that 5 first. We're going to divide everything by 5 so that we can complete the square. What is 5x squared divided by 5? X squared. What is 10x divided by 5? 2x. What is 120 divided by 5? Oh, Lord. I don't know. Minus 24. Maybe I should have known that, but I didn't. 0 divided by any number is 0. So sometimes you might need to divide first so that we have a single x squared. Now the next step I'm going to do is isolate the x squared and the x term. I got to move this 24. So I'm going to add 24 away so that I have a nice little space to complete the square. I need to complete the square now. What goes in those blank spaces? 1. How did you get 1?
The square root of 1.
Oh, okay. Another, how else can we get the 1?
I meant the divide.
2 divided by 2 squared. This middle, that coefficient on x divided by 2, half of it. 2 divided by 2 is 1. 1 squared equals 1. So we're going to add 1 to both blank spaces, to both sides. All right, this is great. Any questions so far? Okay, what do we do now? We completed the square, then what do we do? Double bubble, factor. So this trinomial on the left can double bubble. What times what is x squared? X times x. What times what is positive 1? Positive 1 times positive 1. Hey, that was easy. How can I clean it up?
Can't you do
X plus 1 quantity squared. Very good. On the right-hand side, 24 plus 1 is 25. Now that we've cleaned it up, this is called a binomial square. Binomial square. What can we do now? Square root both sides. Don't forget, plus or minus. So we're going to put the plus or minus on one side there. The square root and the square cancel each other out and leave me with what on the left-hand side? X plus 1. Equals plus or minus, what's the square root of 25? 5, good. And then how do we get x by itself? Subtract 1, subtract 1. And I'm just going to shove that 1 in front there. Negative 1 plus or minus 5. Is this the final answer? No, we got to work that out. So it could be negative 1 plus 5 or negative 1 minus 5. What's negative 1 plus 5? 4. What's negative 1 minus 5? Negative 6. So x equals negative 4 and negative 6. All right, any questions on those? Raise your hand if you think you get this process. Okay. Kind of combines everything we've been doing. All right, we got complete the square. We've got factor, square root method. Emma. The first part of complete the square, right here. All right, we've got one more example. Good. All right, example 3. Example 3, solve for the roots by completing the square. Thank you. Okay. Letter A, we have negative 5x squared plus 100x minus 680 equals 0. What should we do first, ladies and gents? Divide, yes, we've got a number in front that we have to get rid of, so we definitely want to do that. So let's divide everything by negative 5. And again, as long as you divide everything, as long as you multiply everything or divide by everything, we aren't changing our equation at all. How does that clean up? X squared, then what? Negative. Positive divided by negative is negative 20x. Ooh, 680 divided by 5, you know, say 136. Okay, that's going to be positive or negative? Positive. Negative divided by negative is positive 136. 0 divided by any number is 0. All right, then what should we do? Subtract 136 and leave that little space. We want to give ourselves some space to complete the square. So we are now going to complete the square here. Ladies and gentlemen, what goes in that little blank space? How should we find it? Negative 20 divided by 2 squared. What is negative 20 divided by 2? Negative 10. And then you square that, what do you get? 100. 100. So we're going to add 100 to both blank spaces. Does anyone have a question? No? Okay. Super. Now on the left-hand side, we've got this gorgeous trinomial that factors so well. How does it double bubble, ladies and gentlemen?
X minus 10.
X times x is x squared. What times what gives me 100? 10 and 10 or? Negative 10 and negative 10. You'll notice that number is right here. Okay. Now how can we clean that up? What makes it super pretty? Jack.
Isn't it X minus 10 squared?
X minus 10 quantity squared. Very good. Equals what is on this right-hand side? Negative 36. Very good. Right there, negative 36. Okay, great. What can we do now? Square root both sides. Square root, square root. Don't forget the plus or minus. The square root and the square cancel out, leaving what behind? X minus 10. Very good. Equals. Dun, dun, dun. What does this one have? I. There's an I here. This is the square root of negative 1 times the square root of 36, rather. And what is the square root of negative 1? I. That's the thing we've got to remember here. There's an I. So this becomes plus or minus. What's the square root of 36? 6. What's the square root of negative 1? I. So we get plus or minus 6i in this case. And then how do we get x by itself? Add 10. Add 10. And that's just going to insert right in front. X equals 10 plus or minus 6i. Can we combine these? Do we get 10 plus 6 is 16 i's? No, we do not. These are not like terms. One is imaginary and one is totally real. They don't mix. It's like oil and water. All right, they don't mix. This is our final answer, which is kind of easier. Yes, sir.
Can you graph this at all or not?
So you can graph it, but you have, what we have is an imaginary axis and a real axis. And so you would graph like 1, 2, 3, 4, 5, 6i and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it plots up here. Yeah, so that would be 10 plus the 6i, and then 10 minus the 6i would be here, negative 6i and the 10. So it's kind of weird. It's very different. We won't be doing that. Good question. All right, let's look at B. Last one, ladies and gentlemen. X squared minus 10x plus 73. Do we need to divide first?
No.
No, what should we do first? Subtract 73. That's a pretty crazy number, isn't it? All right, we've got x squared minus 10x equals negative 73. And we're going to add some blank spaces to complete the square. What goes in those blank spaces? How do we find the blank spaces? 25. How'd you get 25? I have a mask on. I can't fix my pen. Okay. How do we calculate this value here?
Divide negative 10 by 2.
Negative 10 divided by 2 and square it. What would that be? Negative 5 squared, which is always going to give us a positive value. In this case, 25. Negative 5 quantity squared gives us 25. Then what should we do next? Double bubble. Double bubble. X times x is x squared. What times what is 25? Negative 5 times negative 5 gives us a positive 25. It's also this number right here, which is kind of nice. And then we can condense it to be x minus 5 quantity squared. All right. I don't know what that right-hand side says, so negative 73 plus 25 is negative 48. Ooh. Then what should we do? Square root both sides. Don't forget the plus or minus. The square root and the square cancel out, leaving just x plus 5, conveniently. Now, this, we've got some work to do. I'm going to simplify that radical. And when we're simplifying the radical, we have to look for perfect squares. Perfect squares are 4, 9, 16, 25, 36, 49, what's next, 64, what's the next one? 81, okay. So these are perfect squares that we're looking for inside this 48. So I'm going to break this up a little bit. I've got a square root of negative 1. And 48, turns out that 48 is divisible by 16. And that's super awesome. We want to look for the largest perfect square in order to simplify those radicals. Aiden, can you wait 2 minutes? Okay. All right. So first we have a plus or minus. What's the square root of 16? 4. What's the square root of negative 1? I. And then what's tacked on to the end? Radical 3, which is something I cannot simplify. All right? That doesn't have any perfect squares trapped inside, okay? This is the part, if you're making a mistake, this is probably where today, so pay attention. And if you need help simplifying these, that's definitely something I want to help you with. All right, how do we get x by itself? Add 5, add 5. So we have x equals 5 plus or minus 4i radical 3. Totally imaginary craziness. Okay. Ladies and gentlemen, do you have questions for me? Okay. You have an assignment in Delta Math. You absolutely have work to show, so practice. Label in your notes, practice 3.5. And we will spend today and tomorrow doing this because we want to get really good at it.